be able to know the 5-number summary quickly and easily is always least to greatest. Laura, 1,000 points right there. And let's do this.
I found him. What's he doing? I don't know.
The 5-number summary is the following values.
He's talking to someone.
From least to greatest, min, Q1, median, Q3, and the max. Nice answers. If you put the 5-number summary in the chat, you get 1,000 points. Keep these answers coming.
What is it? What happened?
Hey everybody, little Stranger Things to start off the office hours. How's everyone doing? Do we have anyone in the chat? Might do some coding in R. I didn't send out announcements today. I've already hit people with so many announcements. But let's see. Let's go check out. You know what? NFL Fast R. There is a package called NFL Fast R. And it's pretty cool. So we're going to check that out right here. NFL Fast R. Do we have to do a different repos? I don't want to do a different repo. I just want to do NFL Fast R. Let me see if it downloads, and then we'll check it out. Installed out packages NFL Fast R. Does it load? Is it doing it? Looks like it did it. Library NFL Fast R. Cool. NFL Radar. What do I have here? Okay, let's check it out. Okay, if you're in the chat, feel free to say hi, and let's look at some sports data. I was reading the sports yesterday. People knew it, Philip Franco. 320 NFL data in R. Okay, let's go check this out. Okay, so this is how you install a package. So I've talked about this a little bit in 320. You only run these commands up here once, because they are going to download it to your computer, which is fine. It's downloading it and installing it. And then once you've installed a package, that is basically a bunch of things. Think you're getting a package for Christmas, and you get a bunch of different packages right here, which have all different things in it. They can have data, they can have functions, they can have vectors, they can have help files. They've got so many different things to help you out. And these are all different libraries and packages. We call it a library afterwards. You download the package, it turns into a library, and you get all these things. So you really only run this one time right here. I'll run it again. And it has to be in quotes right there because it's going to search the CRAN server for that package. This red text looks really scary, but that just tells you something is installing to your computer. Like let's say someone sent you code and you ran it and it did this. You'd be like, whoa, 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 what are you doing installing to my computer here? But we want to do this because it's reaching out to an official site right here, and downloading and installing it is successfully installed, and thus it's been added to the packages right here. So if we go to NFL Fast R, there it is right there. Functions to efficiently access NFL play-by-play data. Download NFL verse data. So I was using another one there. So there's my NFL packages. So now what you want to do is, a lot of times if I'm doing this, I'll comment this out, because now I don't want to really run that anymore. You notice right there, we could delete this extra line of code I wrote. This is no longer going to run because it's just a comment right there, because I'm not going to run that again. You only need to install it one time. A lot of times you might go here and then go question mark NFL. Can we not do it there? Oh, darn it. You could go and take a look up here at your NFL Fast R package by going and loading it first. Library. Now this is booting it up. So this is the NFL Fast R library, and it's what you created by downloading the package. And now we have booted it up. You notice it took a second right there. I think I'm using an older version of R, so I need to update my version of R. And then we're going to go up here to this and click and look at the NFL Fast R package. Promise means that it's there. It's like, I promise it's there. We have a whole bunch of things inside of here for calculating reports, NFL verse, site rep. I don't even know. Fast Scrape Roster. Ooh. So let's see what Fast Scrape Roster does. Fast Scrape Roster. Load teams rosters for multiple seasons. Oh, cool. And then they usually have examples down at the bottom right here. Fast Scrape Roster from 2019 to 2020. So let's run that, see what it does. Ooh, there it is. And you notice we have a ton of data right here. This is a Tibble. And it looks like this is going to be easier to see if I do the following. Store it into data right here. We're just going to store what that created into data. And I'm going back to the global environment, which is where you store everything. These are your packages you've attached. And the global environment is just where you're going to see the things you're creating. So these are all the rosters for the NFL from 2019 to 2020. Let's go take a look at that data we just got. And there it is, season 2019, prize the player, defensive back. Is that what DB is? Dolphins Bennett, maybe. Patrick Peterson. So there you go. Date of birth right there. All the info on the players. Who is the... Got 1972. Holy moly. Who that? That is in 1972. Where was their name? I saw it. Adam Vinteria. He's a kicker, right? He's a kicker? Kickers. The kickers are hanging around. Matt Bryan, also a kicker. 1975. So, man. Woo! Man. Getting upper 40s right there. So you look at the NFL and the average age. We could even look at the birth date for the average age. And you know what? I think that'd be really cool. We could do a graph of the players by age right here and do some stacked histograms of this to look at the positions and the players and the age over these seasons. We could look at heights and differences. Frankly, some of the quickest way to analyze this will be what we're doing in 320. So watch this. We're going to go here and load up the 320 library. And so we already have some data to play around with. And we're just going to remove this question mark thing that we're using right here. And let's go to associate, and we are going to associate the height of a player. There's height, and we're going to see if height can be explained by the position. So is there some sort of association with height, position? We don't want that position. If you notice very carefully, that has a lowercase p. This had an uppercase p. This is a function called position from the base R package. That's the name of the package. We don't want that. We want this lowercase p inside of this data right here. So we're going to have to tell it that it's inside of the data by going data equals data. I called it data. You could have called it NFL. And now our data is called NFL. A lot of times I'll call data data, but when data equals capital data, it gets a little confusing. But this says your Y variable that you want to understand is height. Your X variable is the position of the player. And then the data frame name is that. So those are what we are using. And I like to make my code look pretty with each argument on a separate line. So this is going to run all the analysis for us and create a graphic. So I'm making the screen a little bit bigger. And this is, we won't quite get to that this week, but if you notice, yes, I do want to run it. That's why I ran the code. Woo! Okay, it looks like we have to do a little bit of cleaning of our data first because height is being seen as a categorical variable. This actually goes to 201, where we're making a mosaic plot in the bottom right corner where I'm currently at. So you have to have a little, once again, we'll talk about these things throughout the coming weeks, how when you have categorical data, if you notice right there, the Y is categorical, the X is categorical. I should have done the number one thing we do in analytics is check my data and clean my data. And if you notice right here, height, where is it at? Height is said to be a character vector, and we don't want height to be a character vector. So to fix this, we're going to go to NFL $height, and then we're going to overwrite it with as.numeric NFL $height. So this is going to take the vector we already have, create it as a numeric vector. So we're saying make this as a numeric vector, and then overwrite it. So if you look what happens right here, the height vector, oh, did I just rewrite? Where'd it go? It didn't change it. It says error. Is that the data? Oh, I think we're fine. Here we go to height. Yeah, it did it. So the problem is I still have that old data thing up there. So I'm going to go to remove data right there, and that data thing's gone. There's height. And if you want to do the same for weight, you could just take right here and go weight. And this is why copy paste is your best friend. And if you take a look right here, weight is now also a numeric vector. This is going to change the way the analysis is done. So now when we rerun this code right here, it's going to actually compare up. I think it's mad about external. Oh, I think it's mad about we didn't have a big enough space for it. So it has to, big graphic. We got a lot of positions right here. Wow. Oh no, what happened? I've seen that a few times. Hopefully that doesn't happen every time. We'll see if it does it again right here. And if you're in the chat, feel free to say, hey, Mubot is awake. We crashed R. It can happen. I do hope we don't crash R every time. Let me go down here to my latest untitled document. There we go. We're going to put the code in order now, because if I'm doing things in order, we want to make sure we get our data. There we go. We rewrite the vectors. We load reg class. We're going to make this a good bit bigger over here, and hopefully it doesn't crash it. R's acting a little slow. There we go. Okay. we crash twice, I get worried. And I'll run it a different way. I did hit enter. Whoop, there we go. Okay. Everything's loading. Oh, it worked fine. Every once in a while you crash. Something goes wrong. You never know what can happen. And visually speaking, and these are the heights of players. Offensive linemen are some of the tallest players right here. There's so many graphics that it wasn't properly created. I'm really interested in these side-by-side box plots. So I might remake just this portion. This is one of the quickest codes I know how to write right here, the associate function. It's also going to let us look at the means and medians. Tight ends are taller. Running backs are shorter, generally speaking. Everything's pretty symmetric if you look at the box plots. A little bit of skew on the defensive linemen. But yeah, the tallest. I wish we could order these. There's a really nice function we can use right here to look at all the means. So let's go to aggregate. And let's aggregate the y variable of interest height by position. So we're still doing the same thing right here in data equals NFL. We're going to put each of these on separate lines. And then we need to say, I think it's fun equals mean. No, it's not fun. It's not fun equals. Oh, I didn't put a comma. There we go. And here are all the mean heights of these positions. And we should be able to sort it. It's making a data frame. So if you want to cheat, you can make a data frame out of your code and then go ahead and look at this right here. So the tallest players in the NFL are generally offensive linemen, tight ends, which is interesting. They have a average height of about 6'3", 6'4", quarterbacks, and then your shortest players. Why is there no kickers? Where'd our kickers go in here? I thought we had kickers. We had kickers. Oh, where are they? Running backs are on average below 6 feet tall. I'm kind of shocked by that. Pretty interesting. Maybe it's something about being quicker. So, I mean, like you just kind of, Danny Woodhead. Hey, what's up, Nick? Good to see you here. We're looking at some NFL data. I've got a huge data set right here. I thought we had, let me go look at so what we can do is we can go to unique, and unique tells you all the unique values of something. So there's so many codes that you kind of learn over time. And we're going to look at the unique values of position. And there's spec, tight end, wide receiver. There it is right there. Special. Oh, so was I position? I thought for sure we saw when we went to the oldest players in the NFL. Oh, depth chart. Depth chart. What happens if I do this again with depth chart? So let's go here to depth chart. I'm going to cheat and go attach NFL. And now when I type depth chart, it'll show up. And here's the, we save it as a data frame. Here it is. If you got questions, Nick, let us know. We're just taking a look at some of the code right here and what we get. So these are the tallest players in the NFL by the depth chart. OT, offensive tight end, maybe? Offensive tight ends have the tallest, and we could also add the sum to this, or the count of players in this position, because we want to know if there's only a few players. The shortest players in the NFL are still the running backs. Running backs are the shortest players. What's really neat about this analysis is we can quickly change it over to looking at something like the weight of players. I think we did change the vector weight, so we can easily go over here and take a look at the weights. Heaviest players in the NFL are the NTs. I don't know what an NT is. New tight end, like they're new. OGs, the OG players in the NFL. And the lightest players, the kickers, the defensive backs, I guess, wide receivers. So you got to be quicker, or you're going to be running the ball more, I guess. I'm surprised running backs, because we saw they were shorter. Running backs are over here. But you know what we should be doing? There might be outliers. We can easily change this over to median right here. We could be saving all this analysis right here, but it's just kind of fun to like look around and see what you see by changing things. We could turn this all into multiple tables, just trying to make it look nice and pretty right here. And I guess I'll show that, because this is kind of showing what's possible and what we can do pretty easily, just with a few small codes and a few small changes to it. So, and Nick, if you have, let me appear on the screen. If you have any questions, Nick, let me know. I'm just kind of showing for 320 especially. We might use this a little bit. I might have them work with the NFL, one of the data sets, and do some data visualization or data searching around, see what's possible. There's an NFL data, there's NFL FastR, MLB FastR, but there's NHL FastR. And yeah, you can do all different things pretty quickly with it. And especially if you go over here and we use another library that I have. So if you don't have this library, we'll go to GG Easy. Before running that code, you'd have to do install.packages GG Easy because that installs it. So if you don't have GG Easy, you have to install it first and then run the library to turn it on. So you'd want to unhashtag this if you're writing the code with me. And so then over here, you would see GG Easy right there. So with this, GG Easy is a library that makes doing things with ggplots really easy, such that if you go to ggboxplot, where is it? Did I forget the name of the code? Easy. There's all the. Oh no, we don't want GG Easy. We want GG Easy is good. We want install.packages. I already have it though. ggpubr. This is for publishing things with ggplots. And so library ggpubr. There we go. Because a bunch of people basically create stuff. The base R doesn't have all the nice things that I'm using right here. So now when I go to ggboxplot, there it is. That's the name of the library you have to have running. So if you don't see this appear, you don't have ggpubr running. So a lot of times, and I will show this, sometimes people go here and type ggpubr and then go inside of it. So this is looking inside the library. I know I'm hitting you with a lot right here for 320 watching this, but these are all things that you practice and learn over time. So you don't actually have to load the library. You could actually call the library, go within it. This code right here that : means go within the library and grab something within it. And I prefer just to load my libraries, even though it's going to take up more memory. I'm fine with that. Got a good computer. So we're going to go to ggboxplot right here. And what I really like about this is it makes making box plots easier. So if we take a look at the code down here, they're going to show us how to make it. They're going to show us all the arguments. Looks very complicated. Till you go to the bottom and you see you just need to put in the following. We're going to move a lot out right here. We're going to move only down to the following. There we go. So you say, okay, what is all this? Well, the first thing you have right there is a data frame. The next thing you have, I believe, is your Y variable of interest. No, it's your X variable. Dun, dun, dun. So they're making a box plot from the data frame. They're using the X variable dose and the Y variable lens. So when you look at our box plots, we would want the X variable to be somebody's position. And so the X variable needs to be position. And now make sure it's in quotes for this one, a little bit different. And then let's look at the weight of players right here. And it's mad. So, because we didn't do the right data frame. There we go. It's mad about the palette. This is a weird issue, and I hate to say it. I think I have to restart R. I think maybe Reg class did something to me. This is the second time I've had to restart. There might be a way to fix this without restarting, but let me save my work. Oh, I hit the rainbow button. So I'm going to save my work. I'm going to go to File, Save As over here. And let's write NFL examples. And the work has been saved. I'm going to close out. There we go. And you'll see me restart here. And now we're restarting R. Got the officers on the screen. Nick, if you got any questions, let us know. I'm going to make sure the rainbow got turned off. Rainbow is still on. My multi-buttons got turned off. So for some reason, every once in a while, the palette will get messed up, and I've seen that. So I'm actually going to, let's see right here, load the library, load the data, rename the vectors. I'm going to not do the reg class stuff. I'm going to comment all that out. I'm going to attach the data frame. You can do all this stuff. Load up my libraries. And now, there we go. There we go. Nice and neat box plots. And what's really cool about GG Easy is you can go here to plus and go to GG title. And we'll say NFL player weights by position. And it says we have an error. Nope. And there we go. We've got that. And next, let's see, respond to text. And here we go. We're going to do one more thing right here. We're going to go to plus easy center title. And now the title is centered. and we're good to go. But I'd really like to add some colors to all this right here, some colors to the box plots. So let's see, there is a palette. So we could do it individually, but I wonder if, let's go to the question mark on this, GG box plot. And let's see here, the palette. So we've got fill. Oh, we could just do fill equals, and then position. That'll change the fill, and it'll do it by default right here. So if we go to fill equals position, there we go. Nice. And we could remake it. I think it might not go across the screen then. That still does. That's pretty good right there. Pretty nice. And then we could move away the legend, because we kind of don't need, they're right below it. So let's see here. Legend, no. And this is where I even have to check, is I got to go back here and be like, okay, well, how do we need to remove out that legend right here. So these are all the options we can do. Every one of these is a different option. And GG theme, GG Pavar. Let's type in legend up here. Find in topic, legend. Legend titles, labels, positions. Legend equals right. Legend equals NA. Oh, I was mad about that. It's on the right now. Legend equals none. Whoa, it did it. There we go. Legend equals none. So now pretty much I'm getting this to where I want it, to where we have a really good display. I wonder if, here's what I wonder, if we could order these box plots by the median, or by the median. That actually sounds like a much more difficult task to me. We might actually have to code in the order for each one. So that is a more difficult task, but what's really cool now that we have this way we want it, we could look at any vector we wanted, like height. You see the height differentials right there. So we would just change these things. So once you get something the way you want it, you can easily make some changes right here and take a look at the differences, to where you can see, like, okay, wide receivers, there's a lot of variation. And right here, I think defensive lines must have fewer players. Where's the QBs at? There's the QBs. But you can do all this analysis right here. You know what? I really wonder if we look at the year someone's born, and if we can do that, because year born is a date vector. And so I wonder if, because we're going to see some differences there. And so let's go to the year someone's born. What's that vector called? I just saw it a moment ago. Birth date. Okay, so since I've got it attached, I can type birth date right here. There it is. I'm going to copy it. And let's just see what happens. This is what I like to do. Okay. Well, wait a minute. Oh, neat. So they are all pretty similar. If you look, there's not a lot of differences, but then there's a whole bunch of outliers. And the ones with, there's outliers throughout every box plot. Interesting. QBs and special teams have the lowest medians. So the newer players are the running backs. Man, they have a median age, and we're going 2 seasons back, of like 1997. So that means they're about 25 or so, probably just finished college or so. And then you see the offensive linemen, the QBs, and the special teams and you see special teams. If you're born in the 70s, it's like, it's not that unusual. Being older on special teams is not that unusual. Even quarterbacks, an older quarterback is not that unusual. But an older running back, like if you're born in the 80s and you're a running back, oh man, think of who's our guy from UT? Trying to think of his name. UT running back, did really well. Shouts to him. I can see his face and I can't think of his name. But running backs, maybe like the tenure in the NFL is not as long. I don't know NFL statistics as well, but someone else might be able to explain it. But if you look to where offensive line has a little bit longer, that's interesting. They're on the line a lot. QBs and special teams. And I'm not, what's interesting to me, if you look, QBs and everything has the lower, there's not as many, these are where the older people generally are. There's no one born up there with the QBs. And once again, NFL, I'm a huge fan of sports. Got my sports shirt. What type of graph is that? This is called side-by-side box plots. Nick, thank you for asking. Side-by-side box plots. Let's throw Nick some 50 points right there. These are side by, like, isn't it interesting that, so outliers are the dots down here. Does that make sense? Outliers are the dots. These are like, it's unusual to be a running back and to basically be born in the 80s. But the quarterbacks, I wish it put the 1980 down here. Quarterbacks have people born in the 1970s. So quarterbacks, it's not unusual to be born like a long time ago. Not the 70s that long ago. But so pretty interesting right there that we see, you know, you can be born in the 70s and it's like, oh, well, yeah, quarterbacks hang out, you know, Peyton Manning, Tom Brady's still around, you know, and he's born in the 70s. And then over here in the running backs, it's like, oh, you're born in the 80s? Woo, that's old. I mean, not that I'm old, but so it really tells you the differences between running backs and quarterbacks have a lot more variation, and this is called the IQR right here. The box of the box plot from Q3 to Q1 is the middle 50%. So the middle 50% of quarterbacks have an age between about 1997, where they were born, and about 1990. That's the middle 50%. And this is data from 2 years ago. So what's really cool about this is we could update our data set. Dun, dun, dun. Let's see if it updates. Okay, so we're going to go here to the more recent data and go to 2022 through 2023. We'll see what happens. It looks like it didn't run. Maybe we're in the 2022 season, so it can't download that. Okay, that's running. That's running. And so now we have the most recent season right here. It looks like season. There we go. The 20. Oh, so it got the last 2 seasons. So it's, and this is the 2022 season. Oh no, sorry, you got injured. That's a bummer. And you could look at the oldest players in the NFL now by running this and going right here to birth date. And we see some 1977s. Tom Brady, 1977 right there. So Tom Brady is the oldest person in the NFL. Probably people knew that right now, but 1977, Brett Favre hung out for a good bit. He was a grandpa in the NFL. Fun fact there. But yeah. But people in the NFL right there. We got the top 3. Was that Tom Brady twice? Because they changed. No, Tampa Bay court. Oh, it's 2 seasons. Ha. Let's go to 1 season. So we're going to go to 1 season right here by removing the 2021. And now we just have 1 season of the NFL. So we're not doubling up on the data. So this is the latest season of the NFL right here. The oldest players in the NFL are as follows. We have Tom Brady, Jason Peters, Andy Lee, and Robbie Gould. I think I had Robbie Gould in one of my leagues. He's a kicker too. Yep. Picked him up for 1 week or something. So now that we have all this data right here, we can rerun the analysis. It's literally going to run the exact same way. And this is what's great about code. If you write your code the way you want it, you can go back here and look at the birth date. So let's change this to NFL players' birth year. And by position, and let's rerun it here. And there we go. And Tom Brady, QB, he should be showing up. So I'm a little interested in this because I don't know why we're not seeing the Tom Brady outlier over here. Let me do the following. Let me save this graphic into P, which is just a lot of times where we put a graphic right there. And then let me go to library, Plotly, and then go to ggplotly and turn this into a Plotly graphic. So now I've made this an interactive graphic, and I just want to pull this axis right here. There you are, Tom Brady. Now, why were you not appearing? We might need to redo some of the... So that's concerning. If you look at your data and it doesn't make sense, you might say, let me fix my data. We could take a screenshot of this right now, but really, we got to include Tom Brady. I don't like that this axis doesn't cover it, so we're going to have to fix our axis right there. So we need to go to, I think, scale y-axis. Let's fix this. Scale y continuous. Okay, let's go from a sequence from 1975 to 2005 by 5. Let's see if that works. To close, it shows you where you close each one. See, it's mad about that. And then it says it's still mad because I added this within the ggplot, didn't I? It says you got problems back here. Oh, because I think those were the closures. Okay. And then we go to plus. Okay, it did something. So let's run our graphics, see if it looks better. Ooh. So what happened is it's changing the... We need to change that X, that Y lab too. We did better, but it changed it to... We need to go as.det. What does the 5 mean, the comma 5? Oh, so check it out. You can run this code as is. This says create a sequence going from 1975 to 2005 by 5. So it creates those sequence of numbers right there. But what's happening bad right here is it's turning these. It's the way dates work. You see, it says 1975 right there, which is weird. Change the label of the y-axis to the first number, and then I change this. You know what we could do? I want to rewrite each. Man, this one task seems so hard to do. I'm always about doing it natively within R. Thank you. Keep asking questions, Nick, because we're trying to tell the story of Tom Brady over here. You can see the running backs once again, and scale Y. Let me look at my scale Y options. Scale Y, date. Look at this. That is what we should be probably using. Scale Y, date. Let's try this. And here's, okay, it ran. We like it when things run. Hey, I used the wrong function. So a date vector going from 19. Oh no, but it's took Brady out again. Brady, no. Looks like it didn't like it. Why do you keep removing Brady? Why do you keep removing Brady? Let's look at how scale Y date works. I don't use this very often. Okay, let's see. You go to examples here on the bottom. Scale date, date labels. No. No. Scale Y, discrete values, time. Sure, let's just throw that on there. Scale Y, time. No. Sequence. Let's turn it into years. Year. No, that's what I want. Let me go turn on looper date right here. No, let's do has dot date. Has dot date. So close. I just wanted to have those values. Let me look at the scale continuous again. We're one step away from the graphic I want. And that's what can drive me crazy. If you have questions, please ask them. I'm just trying to get this graphic exactly the way I want it. We can't exclude Tom Brady, and we got to get that access right. So this is where sometimes you're like people message me and we try to figure it out. So let's look at this. Breaks. We're looking through the function right here. Scale Y continuous. So there's the name of it. Limits. Let's just do limits. Let's try that. Okay. Limits equals cool. Concatenate a vector. Okay. So 1975, comma 1980, 1985, comma 1990, 1985. It's probably gonna do the same thing. Cool. What? Oh, maybe you put in the upper and the lower limit. I think that might be it. Okay, well now we don't see our data. That's not good. That's not good. What happened to our data? Oh, I know why. Because the way it registers the dates. Okay. The issue is, it is registering the dates. Dates are really weird in ARM. It's going to be very small. You'll see the data again. There we go. The dates, because dates are registered, like watch this. If we take the following and go as dot date, I might use the... So if we go here to 01-01-19, there we go. And then if we take this and go as dot numeric, it registers it as that. And which is weird, it should be registered. So they have a numeric value to them. Looks like it's not doing it properly, but that gets the point across. So these are like the numeric values. So what if we go back in time and go back to where it was working a little bit. And I wonder if, I'm just rewinding time because I'm one step All I want is that y-axis to look right. Okay. So this is our graphic where it's almost correct. We got Brady on there. Okay. So need to change this. I can easily change the Y label. I can go to labs and go here to Y. Is it Y lab? It's Y equals, and let's go year born. And we'll go to plus. I think that should do it for the Y label. Nope. It's Y lab. There it is. Or I might just run that. Let's just run this. This is my time to practice. Y lab. Could not find function. Left arrow into. Oh, Y lab. What? What is going on? Question mark. Labs. Title. X lab. Y lab. Is it like overwriting? So labs. Title equals test. Test. Oh, equals quote. I missed my quote. There we go. Test is there. YLab equals this. It's not doing it. It's not letting me overwrite it. Interesting. Let's remove the scale because that's causing the problem. And it's still not letting me overwrite it. Oh. Well. Oh, okay. I know why I think. I think I figured it all out. I think because I'm using the easy plot. I think because I'm using this right here, it wants me to change the axis tiles. YLab is within here. Okay, that's, man. The GG Easy took control. So YLab will say birth year. And now we get birth year. Okay, we fixed that. Okay, and then we will do that. Okay, so we fixed that. Maybe I should look at the easy thing more. So there's the Y label fixed. And then let's go right here. And we want to change the Y axis. So we can change the font size and access. No, we got to go over here. Character vector specifying X labels. Yeah, we did that. Main title and access labels. We already did that. Access limits. Here we go. Access limits. The plot can be customized using the function ggpar. Okay. So we need to use ggpar to do it. So it's the gg parameters, I guess, is what ggpar stands for. And ylim, yscale. Okay, wait. So, oh my gosh, there's so many things. Y text, Y scale, Y limits. I think we need to use that. So we need to go here to plus, ggpar. Let's just do it with nothing and see if it runs. ggpar argument P is missing. Oh, so we need to pipe it. Well, rather than do that, I'm going to make it easier on your eyes, is we are going to do the following. We're going to store this whole thing we've created into P. And now the graphic exists. And now you can go to ggpar and edit the parameters of this graphic. We haven't put any editing in there yet, but we're taking the thing we just created. It now exists as this object P right there. And now we are going to work with it here. And we need to go to, I think, where is it? I just saw it a moment ago. It was the limits. You can Google it. Limbs right there. There's the X limits. And I think it was ylim, xlim, something like that. There it is, ylim. Okay, so it says ylim. There we go. Ylim is the argument right there. And let's check it out. We're going to go to ylim, lower 1970, upper 2005. And it's mad once again. It's not showing it. Invalid date trans works with class date only. So invalid date trans works. So it's working with a date. So let's say, as dot year. We need to use year. Let me try loading up the library. And let's go to lubridate. Okay. So now let me go to year. 1957, sure. Doesn't like that. As dot date. And I want lubridate functions. As dot date time, 1975. There we go. That's 1970. It's weird. I thought lubridate had an as dot date. There it is, as dot date or as underscore date. We have to be careful though when that's the one we're using. So then we want to go to 0101 1970. What? Oh wait, month, day, year. There we go. Okay. Put that there. Put that there. Okay, we did it. Nice. Working with dates. Woo! Different formats of data right there. There it is. We're going to move this up a little bit here to 1975. And there we go. That. We're going to move it up a little bit more to 1977. There we go. We're going to move this down a little bit to 2003. We got no outliers up there. We're going to move down to 2001. And there we go. There's our graphic. And last but not least, we can overwrite P with this again. Overwriting P with this right here. We now have the object stored into P. And one of my favorite functions right here is the ggplotly function because it turns that into a plotly graphic, which we can now see it as an interactive graphic where you could add and remove stuff. I removed the legend, but we can still like do the zoom in feature, which I love, where if you just want to look at a specific box plot, you can hover over and look at the values. The date values are incorrect, though. I guess that's one other thing. So we don't want to convert all those. Working with dates is very interesting. So that's, well, darn. But Nick, what questions do you have? What are you thinking? We've got a lot going on right here. Just holding some random office hours, having fun with NFL data right here. But with this, you can now make graphics of anything you want of NFL data, looking at different players, looking at their different seasons. So what we could do is let's graph Tom Brady over the years. So I'm going to look at Tom Brady's performance over the years and do side-by-side box plots going for every year Tom Brady was in the NFL, looking at his different statistics and kind of graphing those. We actually turn it into an app then that we could pull up any player we wanted. That gets a little more complicated. But I really like working with stuff like this because I know a lot of people like sports. I'm wearing my VFL shirt today. So if we wanted, let's go here and let's ask Google. What year did Tom Brady start in the NFL? When was Tom Brady's first season? When was Tom Brady's first season in the NFL?
Here's an answer from Buccaneers.com.
2000.
Brady's NFL career began in 2000 after he was...
Man, 2000. It's like he's been around for forever in a good way. Okay. So now we are literally grabbing all data. I wonder if it's going to get mad at us. We're grabbing all data from 2000 to 2022. 22 seasons? Woo! Is it going to do it? Wow. So now we have 22 seasons of NFL data if it downloads. 22 seasons of NFL data. I might store this. You know what I'm going to do? I am going to write it. It looks like it did it. No, it didn't. Error. Item 3 has 36 columns in history. Well. Okay, so it's mad at us. Let's go here and see if it just runs for the year 2000. NFL 2000. Okay, so we're grabbing the NFL season 2000 first. And there's the NFL season 2000. Oh, you see, the later seasons have more data. And so they really don't want you doing this way, but we're going to get it done. What we're going to do is we're going to take and do it the long way, because we want to look at Brady over the years. So here we go. When there's a will, there is a way. There is always a way to do these things. We are going to scrape or download all the data from Tom Brady and analyze his performance over multiple seasons and maybe predict Tom Brady's next season. Is he going to do another season? I don't know. I need to keep up with these things. Okay. And now we need one more. Well, I thought we had enough. Oh, because it starts 2000. Okay. So I got to go back in time. Back in time. Okay. Once again, sometimes you got to do stuff the longer way. quicker this way. I'm used to hitting that combination of keys. I've done things like this before. Sure. Is it longer or is it shorter? I do not know. There we go. Okay. So run all code. There we go. And did it get all of them? What? No way. It just got all of them that quick? Okay, and then this also lets us see. Oh, really? It's only these first 2 seasons that have the issue. Only those first 2 seasons. So because of that, we can go back to here and take, and we know where the problem now begins. So instead here, let's go NFL, and we're simply going to change this to 2002, and it looks like it did it. So now our NFL data has everything. Now we're going to have to get the earlier data in there. So let's remove all this nonsense. And there we go. I should have noticed that 2000, but that confirms it's working. We can also clear our global environment. Let's just clear it right here. Rerun the data right here. Get the seasons that we need to merge. And let's see right here. So we have 2 seasons we need to merge in with this. I got to remember, if you know left merge, right merge, that probably would be very good right here. But let's try it. So we're trying to do, I think, we need to merge 2 data sets here. Let me look at how to merge. I gotta cheat. So merge 2 data sets in R, and merging data quick right here. Let me go to Tidyverse where they say how to merge. Oh, here we go. dplyr with data table. Okay, so I'm gonna look this up right here real quick. And we got data sets. Are they using? No. Do not accept. Okay, random person in the corner. Okay. Merge my data frame by this. When do I have a left merge? Left join. So join by. I just want to add more rows. You get better at my left join, right joins. Let's see right here. Ay. Join table, left join, my table, my lookup, read R, dplyr, left join. SQL database syntax for join function on left join means include everything on the left. What was the X data from the merge and all rows that match from the Y data frame. If the join columns have the same name, all you need is left join X and Y. If they don't have the same names, you need arguments such as by this, by that. Okay. So that's going to be the problem right there. Okay. So it's saying it's in dplyr. So we need to make sure we have dplyr loaded up. dplyr is like a data manipulation right here. So there's dplyr, a grammar of data manipulation, and now it loaded up dplyr. So if you don't have dplyr, you need to go to install.packages, dplyr right there, and that will install it, and then you can run dplyr functions. So we should have our left join right here, and we want to put in, so we're going to try a few things. NFL 2000. What happens? Oh, it did something. Let's say joined. And it's doing something. It is doing something, right? I didn't run it. I didn't do something. They should not be changing the names of their data. Season, depth chart, first name, date of birth, height, weight, all this other stuff. Headshot URL. Oh, that's cool. Season, team, jersey number. Well, you know, Brady didn't really do much his first 2 years. This is the bigger data set. There's the headshot URL. Well. Let's get just our Brady data set first. Let's do that task. Let's get just Tom Brady here. So we need to go to NFL, pipe through. Pipe is an option of dplyr to do something. We're going to go to filter and player, I believe. No, where is it? Is it not player? Is it name? Full name. We need to go to full name. Full name equals Tom Brady. There we go. There's Tom Brady for all the years right there. Depth chart position. Interesting that's not filled out. Maybe that's a new thing they started doing. But there's Tom Brady over the years. And we're going to call this TB data set right there. So there's Tom Brady 20 seasons already filtered out for us. So we can just look at Tom Brady's 20 seasons. Man, I wish they had a game-by-game analysis right here to see each game. I don't think we have that much. We might be able to do that because that's kind of what we really want to look at. But we would be making time plots right here of his 20 seasons to see where he's going. And we got different statistics we can look at. So week, is that how many weeks he played? Why does it say week right there? Oh, because it might include the postseason. That's why you go to a longer week, I would think. Yeah, Super Bowl, SB Super Bowl. He won the Super Bowl 2004, I guess. There's Super Bowls. Full name. There we go. That's not interesting. Enter year, draft. Oh, does this not have his statistics for the season? Oh man, like running yards, we want passing yards and stuff like that. It's just got his stats. We know all these things. These are rather obvious things right here. We need to get a different data set, it looks like. There he is, Tom Brady. Weight 225. He never lost or gained a pound the whole time while in the NFL. Good for him. So, not that it's required, but data looks weird like that if you ever noticed. Fantasy data ID number, years of experience. We did miss his first year. I guess I remember that was an injury year, right? And week. Okay, so this doesn't really have anything interesting to graph right here. Draft number. For the NFL? For what? I don't understand. I don't know what draft number is. Let's go back to NFL Fast R right here and see if we have something to get data on the players. So we want kind of a week-by-week player thing. Build NFL Fast R. Team color logos, no. Decode player IDs. Functions, here we go. Fast scrape roster, fast scrape schedule. Oh, here's game IDs. Okay, so this might actually have it. Fast scraper, we probably need that one. So load player stats. Ooh, that's gonna help maybe. Let's go with load player stats does. Load player stats. And load player stats in NFL Fast R. Load player level weekly stats. Seasons, a numeric vector. Can we not specify a player? Am I going to get all the players again? Load player stats. That's all you do right there and store it into stats. Whatever you want to store it into. And seasons, numeric vector of seasons to return defaults to the most recent season. Okay. So numeric vector of seasons to return. So seasons. And it should say seasons. Weird. That doesn't complete. I always hate when functions don't do that. And let's go 2000 through 2022. Will it do it? It looks to be doing it. We might have an error. It looks to have run it. Well, there we go. We might have just gotten all of Tom Brady's seasons now. Should be a big day. Yes, that's what I was thinking. So we're going to attach this again. No, we don't need to attach it. We're going to go to stats. And then inside of stats, we're going to grab inside of this. Let's look at the... Let's first look at it. Glimpse. Glimpse is a way to just glimpse what is going on with data. And here we are. Here's the data. We've got player name, a bunch of no non-existent players. Player display name. That's what we're going to need. And so Tom Brady we're looking for. So let's go to stats and go through here and go to filter. Player display name equals Tom Brady. Okay, we did it. We now have all the seasons of Tom Brady. We're going to overwrite our Tom Brady data set. And here we are. This looks to be every game Tom Brady has played for all his seasons in the NFL. So this is what's really cool. If you want data, you can get data. I think we literally have all of Tom Brady's NFL seasons right here. It's a rather well-crafted data table. 2-point conversions, all these things. What is an important stat for a quarterback? Like passing yards. He should have receiving yards. That's him if he receives it. Here we go. I don't know what those are. Passing EPA. Passing first downs. How many got there? Passing yards after catch. Passing AR yards. Sack fumbles lost. Woo! Sack yards. Sacks. Interceptions. Oh, passing TDs. Passing yards. So we've got passing yards, good stuff, attempts, completions. We could look at, so it's not a completion rate. Usually they do a completion rate. So if we want to make a completion rate, we need completions divided by attempts. So let's do this Tom Brady completion rate. And so we need to go right here. what we're doing is we're creating a variable. So completions divided by Tom Brady attempts. And now we have the Tom Brady completion rate vector, which shows us his completion rate. So let's look at how good Tom Brady is at completing things over time. And do we have a date vector in here? Because this is where it's going to get really interesting. We can make some really nice graphics. Do we have a date for each game? Do we have a date? We do have the season and the week, so we could do it by, he started in 2000. I don't think there's a date of each game. I don't know why they wouldn't store that in here. Player ID, you might have to go in and append this, and there's like the season and the week. So you could go in and make your own sort of kind of time series of this, which would be really good. But so yeah, the seasonality of this is interesting. Okay. Let's look at his completion rate by year. So we're going to actually use and cheat and use a graphic we made earlier right here, the ggbox plot. We're going to take all the code we already wrote, drop it in down here, change the data set to the Tom Brady data set, go to completion rate, put completion rate as the y variable of interest. It's x then y. Fill by, and I think it's just year. No, season. We need to fill by season. And that's going to be the x variable on the bottom is season. And the y label will be completion rate. And there we go. Completion rate of Tom Brady by year. And that might just do it. We might have just done it. There we go. There we go. Graphics a little bit crazy with the text on the bottom, so we need to actually do something right here. We're going to do an easy way of doing this for now. We're going to go here and go easy all text size and just bring it down a bit. That's way too small, but we can work with this. We could make the title bigger, but his completion rates have kind of bounced around a bit. Going about, yeah, look at this 2019 season. Oof, was that his last year with the Patriots? I don't know. Then he went back to kind of his norm, but he had some really good seasons in here. So yeah, he's usually having around 60%. Just this one season right here. If this is the current season, did pretty good completion rate. And what's really great is we can take right here. Let's go to the names of the columns in Tom Brady. So there it is, names, Tom Brady. If we go to any of the columns that a quarterback would have, like the passing yards, we can look at his passing yards right here over seasons. And you can kind of see a high point in here. 2008, I think he was injured. So you can kind of see where he's still doing good. He's kind of leveled off, went a little bit down right there. I guess that's when the Patriots saw. They might have been doing some analytics and been like, ooh, we got Tom Brady on the decline. So maybe if they were running analytics, they saw this and they said, but then he went back, won another Super Bowl, got his 40th ring. So passing yards right here. Let's go to, we don't want running yards. We want, what is it called for quarterbacks? Passing yards, interceptions. Let's look at his interceptions. Here's interceptions by seasons. So really nothing too crazy. His outliers are towards the beginning. Maybe he's changed his gameplay, but this is within his season, the median amount of interceptions. So 2020, his 50th percentile of game had 0 interceptions. And that's pretty good to say half your games have 0 or less interceptions. Pretty good right there on the interceptions. He did have a game with 3, though, which was not an outlier. And there's actually less variation. Well, this is weird. The box plot going to right there. It's interesting that, especially earlier on, I mean, man, he had some really good stuff right here. That's Super Bowl seasons, right? Ooh, this season right here, 2010, was that like his crazy best season? 75% of his games had 0 or less interceptions. That's because the box right there is just a line. That means the min, the Q1, the Q3, which is the top of the box, you can see the median right there. So 50% of his games had 1 or more, 50% of the games had 1 or less, but the median's down here on this one. But the Q3 is right down here, and that's the season where he got injured. So basically, any game where Tom Brady threw an interception in 2010 was an outlier. Like, it was weird if he just threw one. If he throws an interception, you're like, what? Tom Brady throwing an interception? Impossible. But then over here, he throws 3, and you're like, it's 2020. Tom Brady 2020 is not Tom Brady 2010. So you can see how there's more variation, and thus in this season it wasn't an outlier to have 3 interceptions. It was like, oh, that's what happens. Let's go look at the names of the data frame again, so I can just remember the names of the columns and look at those running yards, or what he helped people run with. So we need to look at passing touchdowns. That's cool. So how many passing touchdowns did he get? We had interceptions right here. So here's his passing touchdowns. 2010. Oh, his higher there was in 2007. Pretty interesting right there. I think there was, where's the helping people run the ball thing? So passing yards, interceptions, sacks, sack fumbles. Oh, darn it. Rushing. No, does he not get yards if he, I guess he doesn't. So how often has he been sacked? Because that's, that's going to be not fun. Sack yards. Let's go to sacks and look at how much he's been sacked. Pretty consistent, pretty not much going on right here, but he's actually been better about getting sacked, it looks like, in recent times. A lot of lower medians. Pretty consistent, though. No big trend that I see. I guess sack yards might be the last thing to look at, but I just like kind of looking at data and seeing what we see from it. Sack yards, sack fumbles. But this is all real data. Yeah, so he really hasn't lost that much. 2017 was an outlier over there, but 2013, you just kind of want to look at the median to see the trend in the median going on right here, but he's been pretty consistent as of late. Medians are not fluctuating much, not really indicating a trend. But yeah, overall, Tom Brady, pretty consistent player. Interesting that he's still this consistent. But what's so cool about this is you could easily switch this. Let me make sure I get Peyton Manning's name spelled correct over here. You could switch this over to Peyton Manning. Peyton Manning. Let's get Peyton Manning real quick here. And so Peyton Manning will change to PM. And there we go. We got Peyton Manning right here. And we just switch this over to... Oh, wait. Oh, no. Wait. Oh, we're doing right here. Peyton Manning right here. Peyton Manning. There we go. And we should have it. There we go. Oh, it's got an A, doesn't it? There we go. That's right, right? Someone just saw that and they're like, no. Wait, what? I'm going to go find Peyton Manning. It's an E, right? First one was an E. Peyton. It is an E. That's how I spelled it first. I spelled it right the first time. Don't you tell people I wrote it that way. Because I spelled it. And then it was right. Rewind the tape on that. I know how to spell Peyton Manning. I was like, why is it not showing up? And then we just didn't look at it properly. So it is showed up right here. We've got all of Peyton Manning's games right here. Once again, Peyton Manning, super awesome right here. Once again, I know how to spell Peyton Manning. Just want to make that very clear. So if you look at Peyton Manning's seasons, we can do the same thing right here, running the analysis. Do remember I did get it right the first time, and I thought it didn't work, so I changed it to the wrong way of spelling it. But no, with an E. I've seen that many times. Let's look at Peyton's completion rate right here. We're just going to change this to the Peyton Manning data set. And we could actually do comparisons and stuff, which would be pretty fun. But this is what's really neat, is doing things like this, where you can just run the analysis of Peyton Manning. And now we have it right here, the completion rate. Oh, good last season right there. This is not the completion rate, though. That's the sack yards. It's not the last. That's not completion rate. Here we go. Completion rate, completion rate. There we go. Yeah. And, well, look at this. If you compare Brady, we could stack these. It's very similar. Peyton was above 60%. Really consistent. Really had a high. This might have been his outlier season. Because you remember all the way back to Tom Brady right here. Tom Brady had an outlier season right here. So if you compare these, and let's actually do this. Let's call this, so this is going to be our Tom Brady one. There's the Tom Brady. And now we're going to store the, oh, let's do it the right way. So we want to store the Tom Brady one right here. And then we are going to make this the right way. We're going to do things the correct way for once. And then we're going to store this into TB graphic, Tom Brady graphic. Then we're going to take the code. Mewbots, hey, Shayez, good to see you here. We're doing a little Tom Brady, Peyton Manning, and Peyton Manning right here, completion rate of Peyton Manning. We're going to do a comparison right here, and by year, easy center title, Peyton Manning graphic, there we go. And so now we're going to use a thing for stacking graphics, and what is it called? Tom Brady, 12, is the GOAT, number 12 right there. Peyton Manning, I think he was number 16 here at UT. Nick, good to see you too. We're going to stack these graphics to show them both at the same time. So wait 1 second right here while we take, and there's a way of doing this. I've used many different things. So show two graphics in one plot in R. Combining plots. No, the way they're doing it, I don't want to do it. There's a way I did it, and I might have to cheat and look at code I've done. Okay, I'm gonna cheat. You ready? I gotta pull up the bird work. Okay, so this is my bird work folder. I'm pulling it up right here, and someone's asking me where to show this. Okay, let me see if this has it. So I showed multiple graphics at once right here. Where did I do it? It's a library I always forget about. GG Mosaic. Patchwork right here. It's Patchwork. That's the name of the library. Okay. So we want library Patchwork. Ay, ay, ay. Okay. So library Patchwork. Okay. And with Patchwork, it's combined, right? Is it combined? No. Where'd that thing go? Chelsea Birdwork. Combined is a totally different function. Where's combined come from? Ay, ay, ay. Okay, let's see if we got this. Combined. Well, let's see what happens if we do this. I'm going to change the plots. Okay, it ran. Oh, I'm storing it into combined. Oh, that's what I did. I'm not running a combined. Ooh, look at that. Ooh, look at that. Okay. Let's get legend position none on there. There we go. I wish I need to give them the same common access and I'll be happy with this graphic. That's my only issue with this. And we could maybe just call it like Peyton Manning. Let's make the fonts a little bit bigger on this. Let's go to font size here, 8. Let's go to font size here, 8. Rerun this, store this, run this. Increase size, take a look. Okay, we're doing better. I wish it had the same. So what we might need to do, since they have the same amount of years, we could take and extend out. We could put in. We need to fix the y-axis on Manning's to cover the same as Brady's, and I think we'll have a really good graphic here. So we need to make it so Peyton's axis has all the same values. So let's go to Peyton's graphic right here. And we got the GG box plot. And we did it on the previous one. So we already figured out how to do this by changing the axis. We use the following, and we need to do it to the xlim now. So we're going to do the same thing right here, but it's going to be an xlim issue. So we're going to take the code we just figured out how to do, and this is how we build our knowledge. Go to the Peyton graphic right here. And after we create the Peyton graphic, we're going to say, okay, Peyton graphic. We're going to update it here. And we're going to update the x limit this time. And so the x limit of Peyton graphic will be updated such that it starts at 2000 and goes to 2022. And then we're going to overwrite the Peyton graphic with this. And then we're going to take a look at the Peyton graphic to see if it looks right. And it doesn't. Oh, because, well, we need, what's the month, day, year? Dun, dun, dun. Maybe this shouldn't be month, day, year now. Because season's not, it's just, yeah, it's just whatever. 2000 to 2022. Nope. Maybe I broke the graphic. Oh, we're inside of a code now, because we didn't close that. Okay. And nope. Okay. Oh, what have we done to this graphic? Let's make sure our original graphic's not broken. There's our original graphic, not broken. Oh, because it's not continuous. You know what? I think it's mad because it doesn't have values for those. So we might have to go to Peyton Manning right here. And we might have to... There's a lot of ways to do this. There's some easy ways and some more difficult ways. We want to add blank values over here. And so... how are we going to do this? How are we going to do this? Okay, I got an idea. We'll add it. It's going to get mad at me, I think, if I do this. Okay. Yeah, it'll get mad. It'll say your vector's too long. That's the graphic. We have to go to the Peyton Manning data first. So here's the seasons. Those are all his seasons right there. And what I can't do is I can't go to Peyton Manning seasons. I hope it puts NAs in for the rest of the data. That's my hope. And I want to concatenate this with a vector. So I'll show you what this looks like here in a second, of 2016 through 2022. So what this is going to do is make it so those extra dates are on here. So I took the original seasons vector of his seasons with each one of those is a game, and then I appended to it that extra vector. Now I'm hoping, I think it's going to say error, your vector is too long for the data frame. It's going to say that. Did it? It might have added NAs. If it did, I'm really happy. Because what I'm hoping it did is it added NAs to the rest of the data. Ooh, it might have. No, I don't think it did. It said you can't do this because you can't add a vector that's longer than the data frame. What I would need to do so I could do a little trick right here. It's not, I think I can do it this way. Okay. So what I can do is I need, how many more seasons do I need? I'm doing tricks. Just going to count them, even though it seems rather obvious. 2015, right? 1, 2, 3, 4, 5, 6, 7. I need 7 more seasons, obviously. So what I'm going to do is I'm going to take Peyton Manning rows 1 through 7. Those are the 1 through 7 rows, and call this add rows. And then I'm going to go here to the Peyton Manning data. Let me go before I make the graphic because it needs to be in order. So here's the Peyton Manning data. Here's the rows I'm going to add. I'm going to add those rows to it. I'm going to R-bind the Peyton Manning data with the add rows. So these extra rows right here are fake rows. Now, what I should do before I do this is clean the data a little bit, because we're going to look at the completion rate. We already have completion rate in here. So I'm going to take completion rate and make all those NAs. So because he didn't have a completion rate for those seasons, so they're all NAs right there. Oh, wait. Oh, shoot. I just did it to the Peyton Manning data set. Oh, no. Okay, let's fix that. This is where people are like, you know, if you do things, you can fix them like that. And I don't think we have Tom Brady's completion rate in here. If you have questions, let me know. I'm just having some fun with data for a moment. So I just made an error and I deleted all the Peyton Manning completion rates, but now we fixed it so that we have the Peyton Manning completion rates again. And so we take a look at here, and now we have the add rows. We delete the completion rate in the add rows. We add the rows, and now we have the rows added on and no completion rate for those seasons. I guess we could have also fixed, let's go to add rows and go to season and store seasons 2016 through 2022, and that rewrote those. So we're just kind of fixing this before we add it on. So we've rewritten the add rows to look like the rest of the data, but we've changed the seasons and removed the completion rate. So now we're going to store this as Peyton Manning to overwrite what's in Peyton Manning, and let's run it all in order. And there we go. So now when we do the box plot for Peyton Manning, hopefully we'll remove out this extra code right here. We see Peyton Manning graphic. Did we do it? Yes, we did. There we go. And now that we've done this, and that's fine, I'm not angry at saying there's infinite stuff right there. We've now created that space right here that was needed where we have no seasons. We could add some text probably on the graphic right there to say like no seasons. I think this right here is fine. Oh yeah, we tried to fix the limits, but we weren't able to using that. Okay, now we have the Tom Brady graphic, the Peyton Manning graphic, and look at that. There we go. And this is what you want to do with graphics. I think this is our telling of the story right here of the different seasons. And it's pretty interesting. Peyton, super consistent. Brady has a few he's fairly consistent, especially at the start right here. That I think he only played like one game his first season or something, like last game or very close to. I think the original quarterback got injured. I have a roommate who was a huge Patriots fan. 2008 got injured, but Peyton is super consistent. Super consistent. He has no real outliers on low games. Brady had a few games in 04-05, which were pretty bad games. Peyton didn't really have a bad game until 2009. So shout outs to Peyton right there, doing really well. And 2014 was Brady had quite a few games, really consistent. Maybe that's why his consistency was really high, but then he had a few big outliers down there. And but you look at some of the best games for Peyton Manning. Peyton Manning's, it looks like 3 best games are in the 2008, but then his top 5 include a 2013 and a 2014 game. If you're looking at those highs right there, you got 1, 2, 3, 4 right there. The 5th might be right there. So 2007, really good year. Is that maybe win Super Bowl that year? But this is what you want to do with data analytics. So, once again, NFL, man, that's a tough job right there. I'm glad I don't have to have people running at me full force trying to tackle me to the ground. But you look at this and you see a lot of real consistency. I mean, even Tom Brady in some of his heydays had a game right down here that Peyton had. But, 2019 for Brady was a much lower season. Brady would have been like, oof, that was a season right there. But had a big comeback right here, won another Super Bowl. Trying to think what else we could compare them on, but this is like, I don't know. Nick, are you still here? Did I lose everybody? This is what we can do with data analytics and how we can analyze stuff and, just looking at different players, doing comparisons right here. This is now a multivariate graphic. Think about the 3 variables we have displayed. We have the year. We're using that as a grouping variable. Like, although year is quantitative, we're doing it as groups, like what year, but we're not doing like a quantitative difference between the years. We're just analyzing each as a group. So it's actually like an ordinal categorical variable in this instance. So you think about stat tool 1, ordinal categorical variable, even though year is quantitative, like by nature. We could have done time plots with this. It's going to look not as good with that. Then we have the completion rate, which is a quantitative variable. And then we have a kind of grouping variable 2 of which player are we talking about. So I'll probably show this over here in 201 later today. But this is what I like to do. I like to be able to analyze data, look at data, compare data. You think about, that's just so consistent. The median right there is just a nice flow. Oh, man. I'm always sad when, the end of an era. I mean, Peyton, huge shot, 15 years. That's insane. There were kids who were born at the start of a season, and then they were like finishing high school, and they're like, man, I've been a Peyton Manning fan my whole life. I mean, they've both had extraordinary careers in the NFL, so it's just crazy to think 15 years. Like, how many people do something for 15 years? A lot of people don't have the same job for 15 years, let alone play a professional sport for 15 years. Both started in 2000. I was graduating high school. I've been watching Peyton since I graduated high school right there. But you could do other comparisons. And this is what, if you're wondering why we do stuff like this sort of analysis right here or tracking data, not necessarily exactly what I did right here, but of this sort is what professional sports teams are doing, especially tracking like workouts, looking at videos. You think about like the, New York Yankees. I mean, they have access to so much data. And I'm 100% being serious with you. Like, the New York Yankees are looking at data. I'm sure a lot of other teams are too, but these teams are so obsessed with analyzing tape, with analyzing, like I think a lot of times in baseball now they have so much information they get about like each pitch when the ball is hit. Like they can tell like the exit velocity of the ball when it's hit by the bat, like the amount of data they have, and then they could tell where you're trending. Like they could have you do different workouts and they could be like, oh, this month you improved by this much. Like your bat speed went up by this much. So we have you on this strength program here. You've kind of leveled off. We're going to make these changes right here. Here's where you're trending with your data right now. And you would just show them these plots and be like, okay, you're pretty steady, but we want to keep you there at this because right now you're at the top of the league. So the goal is, hey, it'd be great if you improved, but hey, if we keep you here, you're still the best. And that's where you can do prescriptive analytics, like what decisions do we make to predict the future? Because we've got an unknown future right here. Some might have said Brady's on the decline right here, but Brady bounced back. Somebody said Peyton's on the decline right there. Peyton, I bet, would have jumped back. He would have got another ring. But once again, how many rings do you need? Brady's just trying to get all the rings. He's a Thanos, So what do you expect? But it was fun analyzing this data. We'll see if people have questions. I'm trying to think what else to do with this data as we speak about it. But this is the graphic I wanted. I wanted to compare two players, look at their completion rates by season, and see where they were at. And there we go. You know what we could do? Let's turn it into a Shiny app. That's going to be my final thing right here. We still got like 40 more minutes. So here's where the real fun begins. The real fun. The real fun. Let's do it. Okay. So I need to make an input box for player lookup. And then I want to look up, let's say here, you ready? Let's go to create a Shiny app. We're going to go plus Shiny web app. I guess I can show this part. I went to plus, I'll show you that. Plus Shiny web app. So plus Shiny web app. And I'm going to call it NFL data analysis. And I think we're good. Let me create it right there. Okay, it's created. Okay. So this is the real deal stuff. This is the, okay. Right now it gives you the default Shiny app. And the default Shiny app is just the geyser data set. You have to think about what you want to put into here. This is a little bit more advanced. We do this in like 475. So you're kind of seeing a preview of what we do in business analytics or what we can do. So this is a app that you can literally put on the internet. Like when I'm saying you can put it on the internet, I mean, I have it open in a web browser right now. It'll run HTML code. So this is 100% web compatible. You could put it, you can publish it on your own website. You can put it to the R servers and stuff like that. The Shiny servers, good stuff right there. So let's try to do some analysis right here. Let's try to get this working as an app. Okay, title. NFL player analysis. And so we just changed the title. And now we want to input a player's name. And I haven't done this in a while. That's why I'm always like, I got to keep my skills fresh because I teach courses. I didn't teach this course last semester. Last time I taught it was in the summer. And I got to remember how to keep my skills fresh. So we want to have our NFL data over here. So let's go grab our NFL data from all the seasons. There's the player stats. We're going to load the player stats in back here. We don't need all this, hello, welcome to our Shiny app thing. We're not going to need graphics for a little bit, so let's extend the window. And so now we're loading the library Shiny. Before we do this, we got to load library NFL Fast R. And we're going to call it that. I'm going to hashtag out this code because I don't want to reload the data each time, just for the time being. Because if I rerun this, because I will run it a lot of times, I don't want to rerun the data every single time, like rerun data, rerun data, rerun data. So that's just going to load in the stats for those years. There we got the title changed. We want to change the input to a field lookup where we input a text, but the text has autofill. And I know that's completely possible, but Shiny text box with autocomplete in R. Autocomplete, select multiple. So we need, someone asked this on GitHub, Stack Overflow rather. Someone says the answer is, no, we don't. Yeah, okay, there it is. So we have autocomplete list. Okay, so we're going to get an autocomplete list over here. And just a bunch of random names right there. And the autocomplete list will be stats, $, player display name. That's the autocomplete list. Okay. So now we've got the autocomplete list. That's what we want. Those are the names that'll autocomplete. And then we need text input type head. It's a very interesting set of code right here. Okay. Very interesting. That's a lot. Okay. Let's see. ID equals search. I think that's the name of the box. Let me just run it. Does it run? Probably not going to run. I've never seen... What is the type head thing they have? I've never seen this. That's where I'm confused. I'm like, that doesn't make sense. I don't know that. Type head. Shiny sky. What is this? This is how you find new things. Install packages. Shiny sky. Shiny sky is not available. What? How is it not available? Well, now we can't use it. Well, what in the world? Huh. Maybe they discontinued it. Well, okay. That's a bummer. Well, like I said, I'd never seen that. And now shiny. That sounded really cool, though. I think we just need to use a text input. Okay. Text input. Placeholder. I know I've used placeholders before. ID. Value. I think it... Let me look at text input. Okay. Input ID. Okay, so that should be input ID rather. Oof. There. Input ID. Label. Label is the label it has on top of it. So that should be label right here. Value is the current value it has. Okay, local data we're not going to need. Value key. None. And then it should have with the placeholder. I know there's a way. I'm like, I feel like I have to go and cheat and look up code. Autocomplete. There's such an easier way. Choices. Okay. So select input. Okay, let's do that instead. Let me delete all this. This is just... Okay. And player display name. Cool. And now let's change this out. And we want to go to select input. There we go. Select input. Input ID. Input ID is player choice. And label equals choose a player. And then choices equals my autocomplete list. Okay. It's probably going to get mad when I run this, but that's fine because we don't have the... I'll take a second. I don't want it to take that long. Okay, look at what we got right here. But we don't... Because now we're going to scroll, and this is taking a little longer than I like. So we're getting there. Ooh, it's being weird on this. Why is that taking a little long time right there? We don't like that. Is it because there's so many names? Should go unique on it. This is taking a moment. Oh, it's taking a moment. Let me look at the size of that vector, because I think that vector might be a little bit too long. Loading in a lot of data right here. Let me go look at that vector. Stop the thing. If you have questions, let me know. I think people might not know they can ask questions at any time, and I'll change over to their work. I'm breaking R. We haven't broken R since the start of me using R. So you got to break it. It's just going to pause out right here. Really? Well, I don't want to quit out of R. And looks like we're quitting out of R. Wow, it really broke. It even broke the internet. Oh, hey. Our studio is using up 1.5 gigs of memory, 10% CPU. Closing out of it. Good to go on that. Hey, Seth, good to see you. Do you have any questions, Seth? We're looking at some Peyton Manning, Tom Brady data. And I was trying to make an app to analyze all NFL players. But if you have questions, Seth, let me know. I'm just trying to analyze some data over here for fun. But if you have questions, let me know. So I was creating an app over here to analyze all player data in the NFL. And I think this is the issue. Let me go to unique on this. Unique player names. And there we go, unique player names. So now we got that. Let me hashtag this out again. Let's break R again. You ready? We're just going to break it again. And let's, maybe it's mad about the server function. Let's remove everything in the server. I'm just getting food to wait for us. Oh, no. Awesome. What are you grabbing? Get some Qdoba. Qdoba is my absolute favorite. It's my go-to in the student union. And if you can, go see Vicky down in the pod. Shout out to Vicky right there, who works in the pod in the student union. Okay, now we got this working. Look at this. Can we auto-complete it? Yes. So look at this. This is where we're at right now. We have a box to enter in a player's name. So now we can enter in the name of a player. So that's all we have right now. We got about 20, 25 minutes left. We can type the name of a player, like Peyton Manning, and or not. And you can do that right there. So you can just select a player. Good. Now that we've selected the player, we need to go make some graphics for them. So let's try this. Here we go. In the server, we need to find that player we have. So this is player choice. And let's go right here and do the following. I'm going to fix this up. Okay. So let's go here to data, reactive data. The reactive data is going to be our stats data from the NFL data. And we are going to go to filter equals player. What's the name of it again? Player display name. Player display name equals, and then the input choice ID. So input $, player choice. Wait, did that actually show up now? Huh, that's weird. Don't know if it was working properly or not, but there we go. Okay, so this might be working. So if it is working, I could probably do a few things to check it, but let's just see if it doesn't crash. Not crashing is a good thing. Didn't crash. Okay. And now we could probably go down here. So we have created reactive data. Let's go right here and say, so let's do this. Render text. Render text. So render text. And we want to render text data parentheses, and it should be 1, 2, 3. So let's go here to first row, third. That might do it. And let's go here to, I'll put $name. Okay, nothing crashed. Good. And then let's go here to the top. Main panel right here. Let's put right here text output. And then let's grab the name of it. And Let's go here to name. This is just confirming it's working. Error, could not find file. Oh, because I don't have dplyr loaded. There we go. Argument type list cannot handled by cat. Well, it doesn't like it, but maybe it's seeing it. Where's data table? Let me try to do it, just display it. So library data table. And let's go here to the bottom and go to render data table. That's a shiny. Okay, that's fine. And let's go here to data output. Cool. And then go here to render, or no. Data table output. Ooh, we might have done it. I think we didn't. This is all I wanted right now. There we go. Look at this. We've now made it so and it has a search feature up here. It's a lot of entries, but right now this shows we have the data, so we can go here and go to Peyton Manning again. If I could type. And we now have the ability to subset the data, which is all we really wanted to start to make sure it's working. We do have the data subsectioning or subsetting, so we're good on that. We can now select a player. We could probably subset we could choose stats also. We would want to populate down here the statistics we want for the player. But I don't know. We could do this displaying it, but let's do some visuals instead, because now let's do it by seasons and pick a statistic to look at for them. So we need a box to pick a statistic to plot over time. So we need another select input right here, and the select inputs are going to be, I guess we could be specific on it. We don't need the first like season, week, season type completions. Okay, so it'd start here at completions. So let's go to names of stat. And it starts over here at completions at 11. That's 10 right there. That's 11. And then it goes all the way down to 52. Okay. So we need right here the autocomplete list 2. And we are going to take from the names of stats going from 11 through 52. And that's the autocomplete list 2. Those are all the things that'll autocomplete in our autocomplete box. So we're going to do the same thing with a select input right here in the side panel. We're just going to copy this code we have. This is inside the side panel right here. So we need to add one more thing inside the side panel. And we're going to go here to stat choice and choose a, what is it? Or choose a metric. So we'll call it, yeah, stat choice or metric choice. And now we have choose a metric. We have autocomplete list 2. We're going to run it, see if it works. And there you go. Completions, passing yards, touchdowns, things like that are all in here for whatever player we pick. So we got Troy Aikman right there. Ooh, Troy Aikman was still around? What year did he play till? I don't know. And so we can view all this right here for the different players. Okay, so now that we have that, we need to make our graphic. We got about 15, 20 minutes here to go, but let's talk about making the graphic here, because now we want to plot it over time like we did previously. So we need to make a plot like we did, but we've already made those plots. We already did a ggbox plot. We just have to pick the thing inside of here. So this is going to be interesting because I'm going to have to figure out how to connect this. Like, it's a bunch of connecting of wires. This is the graphic we're creating. Okay, so that's the graphic. And we're going to go down here. And the graphic needs to be made inside of a render. Render plot. That should do it because we're not doing a plotly. Okay, inside the render plot, we're going to store it right here. There's the graphic. I always make a static version. And we're going to store it into output $plot1. And truthfully, we might run it with this. I'm trying to think we still have the data going right here. Or we could just try creating the graphic first as a just base data set. Okay, let's go here to, this needs to be data. I'm going to try it in one swoop. Data, season, completion rate. Oh, we don't have completion rate anymore. We need something we have. Attempts. Not all players have attempts, though. So we won't be able to see it for the first player. Attempts. It's going to say, like, you don't have that variable. Fill equals season. Legend equals none. YLab equals completion rates. Completion or let's do GG title visualization of NFL data. We could worry about names and stuff on it later. Center title, all the good stuff. Let's just see if it crashes. It doesn't crash, which is good. Okay. So a lot of times I just check to make sure it's running. If you're in 320 and you're watching this, I'm always going to run my code to make sure it's actually running. So now instead of displaying the table, we're going to take the plot right here and go to, we're going to go to plot output right here and change this over right here and see if it works. It probably won't display. Could not find function ggboxplot. That's because I don't have the library going for it. So library ggpub_r. And then library ggeasy, because I had easy center title on there. We're going to rerun it. And I bet it can't find... Ooh, it did it! I hate that it's doing that. There you go. Tom Brady. There you go. Eli Manning. There you go. Eli Manning, super consistent. Went up to a really good high in 2019. 15 years also. Him and his brother played 15 years. Shout out to Eli right there. Completion rate. Was that? Oh, it says completion rate. Those are his amount of completions, though, but pretty high right there. So the y-axis needs to be fixed. We could just say metric on the y-axis. Or we could remove this, and it'll pick what it's called, right? Let's see what that does. Is it going to call it that? Attempts. Oh, good. Okay. So now we need to change this to be interactive with what someone picks. So that is going to be found under here under metric choice. And I'm hoping it's this easy. This is where I'm worried. This is where I'm thinking, please work. Oh my gosh. Would you look at that? We have now a season by season analysis right here. And we can even put a second player down below here. But all those graphics I've made can be easily just created right here. And I wonder if, there's one thing I'm wondering, if I could put the picture of the player right here that you look up. If I could do that, this is going to be my, like, one of my favorite apps I've created just on the fly. Because it did have a web URL. So it showed a web URL for the player. And so let me go look at that web URL, see if it works. We're going to try this, and we're going to probably end off here in a moment, but it's under stats and headshot URL. A bunch of NAs there. Dun, dun, dun. Well, we got to find one that's not NA. Headshot URL. So let's go to, we have the Tom Brady data set, right? We don't? Okay. Let's go grab our Tom Brady data set here first. There's Peyton Manning. Okay, Peyton Manning headshot URL. Okay, there it is right there. So it's got the URL, and we need to display this. Private. Well, is that going to work? Let me try on the other browser first. How do I be private? Oh, heck yeah, it works. Okay, there's Peyton Manning's headshot right there. And if this works, we're going to be able to do this right here and have a really cool app on the fly that we can then associate the player. What is the name of the guy who played for UT, went to the NFL, had a huge season in like 2012, 2013. If anyone knows in the chat. Oh my gosh. Streams on Twitch, or he used to at least. Okay, so that's where the headshot is at. We might have a bunch of NAs though, but we'll just, if it doesn't work, whatever. So, okay, so now we need to go here and we need to add a picture to our Shiny, which I don't do that often. Should just be able to add a picture. Add a picture to Shiny based on URL. In R. One step away right now. Render image in Shiny app. Here we go. It's a render image. So I guess we have to render it in the, where's someone displaying it? Render image. Using render image. Okay, the server renders it. That's not what I want to do. Render image from web in Shiny R. Source. It's in the... Here it is, here it is. Got it. I think I got the code for it. Okay. Don't know what their image is. Okay. So we need to go back to our app now. And there's the render image. There's the URL. And they're grabbing like a... That's where they're rendering it. Let me go look at this again. Server, shiny, alt. Source, output. They're saying HTML output picture. Okay. So they're saying HTML output picture. HTML output picture. Okay, wait. They're saying person who responded to this person who asked about it said do it this way. It's only got one upvote though. Source is this. Okay, let's just grab Peyton's picture right here. It's only going to show Peyton for now. That's a static. You might even get mad at me. Say that's static. Okay, so this is what they're saying would work. I'm going to blank it out right here real quick. They're saying this will work. And, oh, it's over there. Okay, so it's working-ish. We got Peyton in the wrong spot. We want him over here. We don't want him down there. We want him over there on the left. So that's because we put him in the main panel. We want him in the side panel. But then we got to make him smaller. So now we need to go here, put Peyton over there. So he should appear on the left now. We're going to worry about making an inner... Oh, he's probably just too big. So let's make it smaller. Render text. You see that? I don't know if you have the options to change the image size on that. Can I change the image size with height equals 400, width equals 400? It's going to be like unused arguments. Yep. Got all mad at me. Yep. Said, what are you doing? Didn't like that. Okay, so... We're so close. Lewis, good to see you here. We're so close to making our really cool app. I've got just a little bit of time left. So close. They're using render image. And you would think that would work. I'm going to use render image like they're doing. So render image. Okay. So we're just going to use their thing that they're saying doesn't work. Render image. Source equals picture source. And there we go. And they're saying it's not working. Oh, server's still crashing right there. Got a little mad, it looked like. Okay, yeah, it's not working. This is a crash. Okay. It doesn't like that? What does render image want? Render image. Let's look at examples down below here. Render image. Width. No. Render image. File name. File path. Do you have a sign there? Huh. Well, we're so close. This is awesome. My goal is to go into Hockey Analytics. I'm still... Yeah, Abigail, that's awesome. We are so close to having this work. And stay tuned for a few more seconds. I'm going to have the picture of the player appear below. Someone's asking right here, is it possible to use web-based images? And then someone has a bunch of stuff right here. But we're so close to having what we want. Render, print. They're saying... you see, we have it, but the image is too big. But you know what? It might work. Is this where we had it working right here? I think this is where we have it working. This is where we have Peyton's picture, but it's too big. Or not. Okay, we got to go back in time a little bit more because we have it. Yeah, this is where the working version, I think. Where Peyton's too big on the left. Got to get back to our working version. No. Is it mad at me for taking source? Oh, that's the somewhere picture. There we go. There's the Peyton Manning picture. Oh, what's going on? Now we're not... Now it's... Oh, no, it's working over here. Okay, it's working over here. We got Peyton's picture, but we're trying to get his picture over here to the left. And so that's my only problem right now, is I want Peyton's picture right over here. And so we're almost there, and it opens on the web, but it's being a little bit weird about that. So we'll get this working. That's my goal before we finish off right here. So thank you for hanging out, Abigail. I really want to get this thing working, and I'm just trying to make a fun little app. You would think that I probably need to put it in a box. You can define a box and define the size of a box. So I think... So box, create a box in R. Create box in Shiny R. Box function, here we go. R document, Shiny dashboard. Okay, so this is, we've been doing this a lot today. We've been loading up more things. So library, Shiny dashboard, and now we get the box function right there. That's fine. Here we go, create a box in Shiny dashboard. Okay, so examples right here. Fluid rows. We might need a fluid row to make this better. And box, status, selector. Okay, so, and then I think we can decide that, yeah, look at this. You can decide plot out. Ooh, here it is right here. Okay, height. Maybe we just define that right here. So maybe we go to this HTML output and go here to height equals 250 and then width equals 250. It might have been this easy the whole time. I saw an error appear super quick. Let's go to open in browser. There's like a scale, I swear, on this too. Like you can scale it. Like, does HTML output tell me it? Stop this. I don't know why the Shiny app's doing weird. Span. What if I go to, because that's we're creating it here with render text. So let's go to text output. It's a horrible idea. What was it mad? It's mad about something. It didn't like that. We're so close. You can get so close to something and be one step away from getting it. I want it right over here on the far side. I just want it right in this box right here. And I don't know why it's not appearing over there. Main panel. Oh, because I need it in the slider first. Okay. So we moved it over to the other side. Shouldn't be in the main panel. Should be over here. And so this is a little bit closer to what we want. I think he's just so large, he's appearing over there on the right side now. You see how this goes down right here? I bet you if I zoom out, yep, look at that. He is over there. But we need to make Peyton smaller. Oh, that's cool. It's a PNG, so he's going to appear in the background. Okay, so we just have to change his size. We have to make it smaller. Decrease size of HTML output in Shiny. Resize widget size. Okay, so where is it? HTML output. No. How are they doing this? Absolute panel. So close. Decrease. Let me write this. Make smaller in Shiny R. Okay. Customize your image output size. Okay. Okay, it's width equals 100. Okay, wait. Here we go. Is this it? Someone has code like that. Oops. Don't think that's going to do it, is it? Can't be that easy. Oh my gosh. Might have worked. Might have worked. If I bring this down to 25%, it might have worked. Let's take a look. Okay. Let's go to 20%. Did it work? Let me open it over here in the browser. No, it's not worked. It's still the same size. We're so close. So close. Why can't we get it to decrease the size of Peyton Manning? He's impossible to decrease the size. HTML output. What is the argument to decrease the size of that? You have to set the dimensions in render image, but we're not using render image. We're using render text. Well, let's change it to render image. And then have it crash. Or not crash. Or not crash. Or not work. Yeah, not work. But they are using... They are using... we can just go render image. That's where I start breaking things. Oh, why? Looks like their code. It looks like their code. We're so close. And now I broke it. This is... Okay, let's see if it's working. Not working. Okay, we broke it. You can take 2 steps forward and 3 steps backwards. That's the way it goes. We're ending office hours here, but we've got until 1:30, right? Class starts at 1:30. And I really want to get this working and then show it in class probably. It's just we're so close. We're trying to connect this. So close. So close. They're using different things. Customize your, because we're using, up here, we're using HTML output. Really close. I think the box might have been the best answer. Can I just throw this in a box? See what it does? Let me just put, I don't use many boxes. So let me go here and just say box around it. Let's see what that does. Maybe it'll do something nice. Box. Sure, put it in a box. Run it. And let's see what happens. Now I might have additional functions on the box. It did work, but can I go to the box and decrease the size of a box? Title, footer, width equals 6. Haha. Width equals 2. And now, did it do it? Darn you, Peyton Manning. You have left the box. It also looks like he's not part of it anymore because previously it extended the color of the kind of bottom thing. So I think that was maybe a bad idea. Yeah, it did. If you look over here, he's no longer inside of this because he's like extending outside of it. So we want to keep him inside of there. We just want to decrease the width. Make HTML output smaller. This should have an option on it, which I swear I've already looked for. Input in container. Container, why didn't I see that? Container, tell me more about the container. A function during an HTML header to contain the text. Container if inline span else if inline. Okay, so if inline, just gonna check if inline is true. Inline, oh, we could do inline true. It's inline false. Let's see what that happens. Inline equals true. Was it really this simple? Was it really this simple? It looks a little better. No. Yeah. Container tags list. Class customer output. Decrease size of HTML output. Thank you everyone for watching me struggle right here. Decrease size of... Okay, someone's asking this right here. Same thing. No. Shiny. They're not talking shiny right there. Web image in Shiny app. Okay, someone's doing it a completely different way here, and it's probably a better way. So I should totally change this up. Image source, but it's got to be created in the server. Nah, it's not going to work the way they have it there. Save it. Oh no, that's no. Image source. Image output in Shiny app. They're doing it with render text too. But I'm trying to make it smaller. No. Surely someone has. Oh, wait, here it is. Image. Okay, wait. Render UI. I've seen that before. Okay, that's it. I think we just found it. Render UI. There we go. Okay. So source equals, and then the name of the source, and then height. They're using Zoro on theirs. I think this is one of I used last time. Okay, so render UI. We're not going to use Zoro. We're going to grab it from a web source right here, which is going to say, let's go to picture source. And now we're going to call the picture source right here. Render UI. Is it still mad about anything? Okay, there we go there. And when you go to, now we have to go to UI output up here. UI output. No. Yeah, it is UI output, isn't it? Output. Okay, open in browser. Come on. It's doing weird things over here now. Is the picture like completely over the screen? No, it's not liking it. Well, that's 2 steps backwards again. What's mad about something? Let's just put in the picture source right here as the name of it. No, it's still mad. It's still mad down. What's it saying the error is? With no defaults, argument height. Oh, this doesn't matter about the height. Okay. So it's mad about height? Sure. Let's do that and see if it likes it. It's still mad. What's it mad about? Argument with no default. Source. What is source? Okay. It's just showing the text now. It doesn't seem to want to do all the web. Here we go. Display pictures from the web in Shiny R. Okay, render UI. This is it. Okay. This looks to be what we're looking for. And then the UI output. So the render, they're using render UI. We want to do that. Output image, okay. Render UI, they're using the R logo right there. And then they're using UI output image. So it should put the R logo there. If we've done it properly, it should put the R logo right there. It's interesting. What we've been working on this whole time for the last 30 minutes is just trying to make this look pretty. So when you think about all this work, there's the R logo. Okay, cool. You can't see it right now, but we've been working on just making this look pretty. And that's a lot of times what you might focus on is just trying to make something look nice, because people will want to use nice things. So height equals 300. Does this have it? Render UI. Looks like Render UI had it in it that we could change the, or maybe not. Maybe I just didn't find something. Or can I change it up above? UI output. Change size of UI output. How dynamically scale UI output with side of all collapses? Oh my gosh. UI output. Did they say how to do it? See if anyone's chatting. What up, Credible? Good to see you here. Plot height in shiny. Width equals. Can I not change the width of this? Oh man, it's so close. Oh, I just closed everything, I think. I didn't want to do that. Nope. So close. Well, let's do this. Picture. Okay, I'm going to do the last thing right here, and I wish I could get it all done. We're heading towards class time at the last 20 minutes. We've got we need to grab the unique. So I've just been trying to get someone's picture in here, get Peyton's picture in here, which I can do. We got Peyton's picture right there. Picture source is going to be right here. That should work. And now when I run the app, it should bring up Peyton's picture right there, which it does, but it's really too big right now. It's just going to have the picture. So let's go do it where we can see the person's picture depending on who they are. To do this, we're going to have to take from, so this is where I got to start thinking again here. Not that I wasn't thinking before. We're going to have to take from the stats data frame, or let's go to stats, $, headshot URL, and what column is that? 1, 2, 3. Which column is headshot URL? Names. Headshot URL. Oh my gosh. There it is. Column 6. Okay. So we need to go to data 1, 6. That'll be good. And the value there, that should be good. And it's going to be reactive data. So it'll be that. Okay. And so picture source. So picture source will be reactive. Open it up. And we go to data 1, 6. And we go to as.text or as.character. And then we go right here. We take reactive picture source. Picture source is now a reactive object. We use picture source as the reactive object. And then we redo this. Don't like that, looking like that. Okay. So now it should maybe work. Hopefully this works right here with the following. Open in browser. Might not have one for the first player right there, but if we go to Tom Brady right here, hopefully it works. There it is. There's Tom Brady. So we're so close, because now you could go to Eli Manning, and all we have to do is change the size of this picture, and we will have our ultimate app. I need Adam Spanbauer here to say, how do we fix this? But if you type in your favorite player of the last whatever, like David Akers. Is he in here? He's not in here. We might not have every player, but if you look up a player who has a headshot, they should be on here, which apparently a lot of players don't have headshots. If they don't have a lot of seasons, they won't be in here, or maybe it's a more recent thing. But you can type in a player. So like, trying to think, Danny Woodhead. So Woodhead. Oh my gosh, he's not here. Woodhead. Danny Woodhead. What? I think that's like a non-existent player or something. That's weird. So there's Tom Brady right there. Well, Danny Woodhead random right there. So all I want is to make that smaller, and then we could look at the passing yards and anything. How do we make that smaller? We got 8 minutes before I'm gonna send the announcement. Let me send the announcement now to class and say, because this thing will be done. We'll have completed it. We'll have made a really cool app. We're so close. Let me send the announcement, class starting soon. And I'll be like, yes. All I have to do is decrease the size of the picture. That is it. And I will have completed my objective of creating an app that you can pick stats for players over the course of the NFL. So I'm going to send out the link to class for people who are in the class. Getting the class. Oh, wait. That's sent to class 3. There we go. Class in 16 minutes. We got people in the chat already. Plus announcements. Class in 15 minutes. See you soon. Soon click here. Okay. And there it is right there. Done. Send. Good to go. Sent to the right class, right? Always afraid of that. Oh, section 01. Okay. All I have to do, we'll save this. All I have to do is decrease the size of that picture. That's my only task left. All I have to do is make that UI output smaller. Doesn't like that argument. It just crashed his... Oh, wait, but that person didn't have a picture. That's why. Should put the default to Tom Brady or someone so we can see a picture to start. No, I don't think that's 50. Let's go to 10% because if it... Maybe I won't notice if it's not that much smaller. Okay. And... No, it's not 10% yet. We're so close. Like, it's too big. It's auto-sizing with it. And like I closed out everything there. 2 seconds. Oh my gosh, what about done? New window. Okay. Change default output size. Using Kevin defaults. Okay. Good to see you, Vincent. Get started here in a little bit in class. I'm so close. Oh, someone said, how can I add a size parameter to the... This is very similar to what I'm asking. How do I add size parameter to UI output for a Shiny R application? They're trying to make it smaller. Based on the acceptance discretion of Final Fantasy Master expressions following code. Leaf... Oh, here it is. Leaf lit output. Okay. What? Render leaflet. Oh, no. Gotta do that? No. Leaflet output. Do I have leaflet output? All right, let's see if I got that thing. Oh, it's a new package. I don't want to get a new package. Leaflet. Okay, we got seconds to go right here. Doing well, Vincent. I want to make this app and make it look so cool where we can look up players. I'm just basically doing what you can do on the web, but install.packages, leaflet. This is my last attempt right here. downloading a new package I've never used before, and checking it out, seeing if it works. Okay, so we're using a new package we've never used before. We're about to totally mess with our code right here. And so now they're in the server creating output leaflet, render you gotta, wait, what? Okay. Render, but no. I don't know if it'll work. Render UI, leaflet map. Output leaf, so they're taking the leaflet map. I don't know. This is very convoluted. Updated note. Okay, so here's their updated code. Oh my gosh. Oh, they are using a URL. They're using URL. Ah, so close. Oh, you can't see it. Well, we're going to end off right here. I'll be back in just a little bit. Bye for now, everyone. Bye.